it's going now. Good. Okay, so number 18, you said. Let me just look it up in my note here. Oops, where'd it go? 18, there it is. So yeah, this is a good example of what you're supposed to be doing for these. Yeah, I think you can see. Okay, so we're doing this series of radical n over 8 to the n, x plus 6 to the n. So it's exciting when you see things that you recognize, like that 8 to the n. You think, oh, geometric series, radical n. I don't know if that's going to be a problem or not. We're going to find out. So in order to find out the interval of convergence, your first move is to write down the ratio test or the root test, but most cases you're going to do the ratio test. So that's what I'm going to do here. X plus 6 to the n over 8 to the n, radical, oh, sorry, I have to put plus 1 on the top, don't I? 6 to the n, 8 to the n. Sorry, it's a little bit of a mess because I forgot my plus 1 until it was almost too late. But yeah, so you do the limit, put the plus 1 on top. I'm going to clean this up pretty quickly. If you don't understand the algebra, tell me. I will explain in more detail. But we have radical n plus 1 times x plus 6 all over radical n times 8. So a bunch of stuff canceled. Technically what I did was I flipped this one, multiplied, canceled the extra 8s and the x plus 6s. Let me just do one more thing. So this is going to equal the limit as n approaches infinity of radical n plus 1 over n times x plus 6 over 8. So I just wanted to separate out the n's because this is the stuff that has the n that I'm going to have to deal with the limit. The rest of it is just x's and 8s and 6s. So does that look okay? Is anyone losing their mind? Stop me if you need me to, Hayden, and I'll explain, or anyone else as well. Okay, so this limit, now hopefully it's pretty obvious to you that the limit is going to be 1 for this thing. That limit is 1. So we're just left with x plus 6 over 8. And I want that to be less than 1. So let's set this up. X plus 6 is going to be less than 8. So multiply both sides by 8. Whoops. And that means that x plus 6 is going to be between 8 and negative 8. Oops. I can drop my absolute values now. So I know it's like we went from something that looked from that, we're down to this, which is almost nothing, right? And it gets even simpler. So x is going to be between 2 and negative 14. So there's our interval. The only thing left to do is to check the endpoints of the interval. But I'm going to make quick work of that. Here's how I'll do it. So we have x equals negative 14. Sorry, it's like I take my glasses off and I can't see a thing. And x equals 2. Let me go back up here to the original. There it is. Give me a sec. Pull this down here. In both cases, this is going to diverge. I mean, I can tell just by looking at it, but just in case you can't, let me go ahead and do this work for you. So if we plug in x equals negative 14, what that does is it makes this stuff into negative 8 to the n. If you plug in x equals 2, it makes the stuff in parentheses there 8 to the n. So the one on the right is the more obvious. Well, actually, they're both pretty obvious. When you cancel those, you're adding up a bunch of numbers that actually get bigger. So the limit as n approaches infinity of this is actually infinity. So this diverges over here. On the left, this thing is alternating. If you think about it, you're going to cancel the 8s, but you're left with negative 1 to the n. Doesn't matter. It fails the alternating series test. This thing diverges. So both of these diverge, and so this here is my answer. You have to check the endpoints, even if it diverges. At least give lip service. Show me that you're considering the endpoints. If you don't consider them, if you don't show me that you're doing it, you will lose points. Here's the deal, is to do this correctly, you have to do all of this. So up here, the algebra, that's only half the story, so you'll get half credit. You have to do this stuff down here as well. I guess that you could, if you're, if you're really, if it's super obvious, you could do something like this. -14, diverge. Just show me that you've at least considered it. That in your head, I think probably if you were taking the AP exam or something, you'd have to write a little bit more than this. But I'm happy for you to at least just say, look, I thought about it, and those diverge, and so that's the final answer up there. I don't know, does that answer your question, Hayden? You got it done? Anyone else for this one, number 18? 18, what do you got, Americo? I'm sorry, how does it what? Oh, okay, so let's take a look at the alternating series test with this one. So here, I'll just go back this way if you don't mind. So this is n equals 1 to infinity of -1 to the n radical n. So when you cancel the 8's, you're left with just -1 to the n. Alternating series, the limit is, first of all, radical n does not decrease, but the limit as n approaches infinity of radical n is infinity, not 0. So, but yeah, so technically it's not failing the alternating series test, it's failing the test for divergence. Or maybe it's succeeding. It doesn't, yeah, it diverges. So the limit is of this term is infinity. So there's no way that it can converge. So anything else about either 8? Well, first 18. 18. There's 18. Okay, what about the other ones? Anything else that we need to look at? Yeah, oh yeah, Maggie? 14, let's take a peek. Where is 14? These are evens. I see a pattern. Okay, so okay, we'll try to do this relatively quickly. So n approaches infinity. I'm going to use the ratio test again. So the hard thing here probably is just keeping track of all of the factorials. There we go. So the trick that I would use is, well, I don't know, maybe it's better to actually write it out. Okay, so this is going to be, let's see, limit n approaches infinity. So I'll write it out. There we go. Okay, so first things first is this n plus 1 factorial is n plus 1 times n factorial. Secondly, 2 times n plus 1 is 2n plus 2. Now hopefully you can do your own canceling. And this becomes x squared over n plus 1. So this particular problem, the limit is 0, no matter what x is. And so this thing converges no matter what you put in there for x. So x doesn't matter. So here, this thing converges for all values of x. You can either say it's the real line or from negative infinity to positive infinity. But that thing converges for any value of x. Anytime when you do your limit, you don't have an x here, it means that it doesn't matter what x is. Yeah, you're gonna be, that's less than 1 here. Let's just write that in there. Yeah, so using the ratio test, it doesn't matter what you plug in there for x. X is irrelevant. You're always going to converge. So there are some that are like that. And I always am happy when this happens because it means I don't have to check the endpoints. So whenever you have something like this, you just write this down. You're all done. No endpoint consideration at all. All right, let's give it a go with one. Now, so today I'm backlogged with my quizzes because of various issues, trying to pack up 28 years worth of junk in my house. So that's my excuse at least. Whenever you see a quiz that doesn't have the corner cut off, it means that we're doing it together. I'll just give you credit for doing it. I know everyone got an A 100%, so don't worry, you will get credit, but we're just going to correct it together. So let me give you this, and then just hang on to it when you get done. So hopefully I'll get your quiz from Friday back to you soon. But if I don't want to get backlog too much, because I know that you use these to study for your final. In fact, Ethan was saying that he wants to have more quizzes so that he can have more study, right? You were saying that you want more material on the final? Oh, less material. Okay, I guess I misinterpreted.
Perhaps more review.
Well, that would work too. Yeah, I mean, and the quizzes are a form of review. Did everyone get one? Everyone got one. Okay, I'll get one for the people watching on at home. Let's see. Oh, which one is this? There it is. All right, if this was a real quiz, I'd say, oh, you should panic now. Finish it up, put that last thing on the left endpoint or whichever endpoint you're working on. Hopefully you've got something down for an interval. So I'll give you another 30 seconds or so. All right, let's go ahead and take a look and see how you did on this. So hopefully it's not too challenging, and when you get to the actual test, it won't be too challenging either. So we're going to set this up using the ratio test. Almost all of these sorts of power series, you'll use a ratio test just by nature of the way that these things usually shake out. So anyway, we're going to set up our ratio test. Make sure that yours is set up like this. I've got this with n plus 1 goes on top, and just rewrite that on the bottom. So double check, did I get it all right? And check yours. So now it's your job to correct your own paper and mark yours down. And then I'm going to just assume that you're fixing all your mistakes so that I can give you all hundreds when it comes to the quiz. Which one is this? Is this quiz 29? What is it? Yeah, 29. Okay. Good. Okay, so then I did some, I kind of skipped a step. Well, I didn't really skip a step. You can see what's happening is you're going to flip this. So the n plus 1 is on the bottom. The n goes on top. As far as the 2 to the n plus 1 over 2 to the n, they all cancel except for one of them. So that's why there's a 2 up here. The x's, you have a similar situation. So n plus 1 of them on the top, n of them on the bottom. So you're left with just x on top. And that simplifies, oh, I guess I did my limit. I got 2x. So that's your first step. You might have had more intermediate steps, intervening steps, but you should get down to 2x. So you know the drill, the ratio test and the root test, they both say that that thing, when you get down to this point, has to be less than 1. So it's got to be less than 1, which means that x must be between negative 1/2 and positive 1/2. Now for the hard part, at least for me, I remember, I sympathize. It was painful to have to deal with the endpoints now that we've got all of this. So let's do the left endpoint first. The left endpoint, when you plug x equals negative 1/2 in here, this stuff kind of combines, and you've got negative 2 over 2, which is negative 1 to the n. That is an alternating series. It is the alternating harmonic series, which we are familiar with, and it converges. When x equals 1/2, on the other hand, you end up with the harmonic series, because 2 times 1/2 is 1. 1 to the nth power is just 1. The sum of 1 over n diverges. P series, you can call it if you want. So converge on the left, diverge on the right means that the final answer should look like this. So if your final answer does not look like this, fix it so it does look like this. Does everyone's look like? Anyone have something different now? Okay, good. So let me just make sure I write this down so I remember. So name is everyone. And let's see the score, 100. How's that? Okay, onward. Let's get over here to power series land. Okay, so more power series, so much fun. So what are we doing now? Well, actually, today, what we're doing is more algebra than power series, interestingly. I mean, you've done some power series, but here's the sort of thing that we're going to do today. Now, the idea behind this is that you already know this power series. So let's write this one down, x to the n goes from 0 to infinity. So let's use this one as a stepping stone. In fact, we're going to use this as a stepping stone for every one of ours today. So see if you can jot down what you think the formula is for this power series. What is the function that that power series represents? Like I said, this is going to be sort of our the basis for everything for today. So if you don't know this one, then you're going to be stuck. Okay, let me remind you. So hopefully you've written something down, but if you haven't, this is a geometric series. Common ratio is x. And so this should have, so the first term is 1, put n equals 0 in there, divided by 1 minus the common ratio, which is x. So there's that, and this thing converges. So the interval of convergence is negative 1 to 1. So you're familiar with this, but you're familiar with it if there was an r here. If this was an r, it wouldn't be a problem. You've got a geometric series. The formula for the geometric series, when the geometric series formula is legal, you already know all this. But once you throw an x in, for some reason it causes people's brains to turn upside down or something. It's hard with an x, but it's the same thing. So it's just the same as with the r. So this is just the geometric series. Geometric. That was dumb. Well, okay, so how are we going to use that to get this over here? Well, here's the deal. For everything we do today, at least, what we're going to do is we're going to do some algebra to try to take what we've got. So I've got that, and rewrite it so that it looks like this. Let's see there. So it looks like the thing down in the bottom left corner. So here's how we're going to do this. I'll do this one for us, and then I'll give you one to do. So this one isn't too bad. What I'm going to do is I'm going to rewrite this like this, which I know is not doing much, is it? But I just wanted to point out that no change is too small. So like here's my thinking, is that down here, my goal to get the geometric series, I want to have 1 over 1 minus something. Well, that's 1 over x plus 1, so let's put the 1 first. That's at least a start. Okay, now the second part, I'll do this. 1 over 1 minus negative x. That's legal, isn't it? That's fine. Sure. Okay, so now here's how this is going to work. Is I'm going to do this. I'm going to take this and I'm going to replace. Now I regret using x over here. You know what? I'm going to get rid of my x's. Let's redo. Just back up just for a sec. Let's get rid of that whole thing because I don't like the way I wrote that. Let's just write this the way that we know it, right? We know this. Yeah, that's much more comfortable, isn't it? There, that's geometric. Let's see if I can do a better job. Yeah, that's better. Okay, so here's the deal, is on the right, I have 1 over 1 minus r. Here I have 1 over 1 minus negative x. And so in this case, my r is negative x. So this thing becomes the sum where n goes from 0 to infinity of negative x to the n, which I can rewrite like this. Negative 1 to the n times x to the n. So this is a geometric series. This thing will converge as long as r is between negative 1 and 1. So this is the series representation for this. Now, as far as the interval, check it out. This is actually so much better than what we did today for today's homework. There. That's a terrible arrow, but you get the picture. So let's make our interval of convergence. That works, doesn't it? Okay, well, doesn't really. what do I have to do? Divide everything or multiply by -1? But whenever you multiply by -1, you have to change the direction of your little alligator. So this becomes 1 is that x. There, how's that? That just looks dumb though. So let's write it like this. Okay, so here's, we'll go through this. I actually have several. I mean, there's a bunch of these to do. You see, they keep going on forever and ever there. But I'll give you one to do in a minute. But I just want to go over the steps here. Take your function, rewrite it so that it's 1 over 1 minus something. Then you use this geometric series formula to come up with the power series, and then use the geometric series convergence interval to come up with the convergence interval, which this one was easy. It turned out to be the same, but let's do one that's not quite the same. Let me look at this next one. The next one's different. So this one should be fun. So let's take a look at this really quick and try this one. So let me just remind you, you're going to well, actually, there's not much to rewrite, is there? This one, I think you can just identify. R is equal to what? And then you can write this as a summation. Using the geometric series formula. And then we can also do an interval. Here, I'll even do this. -1 and 1. We just have to fill in the blank in the middle there. Oh, yeah, I can pick people. Hold on a minute. Oh, that's not what we're doing. Let's see. Calculus. All right, Americo, what is R for this thing? It is 2x, yeah. So if you remember, and it's not on, I'll just jot it down here. We had 1 over 1 minus r. That's kind of the model that we're using. So r is 2x. Very nice. So I'm going to just throw a 2x in here. And that's going to be this. So here, this is my arrow. Let's see if I can do a better job with an arrow here. Still not very good. But what you want is this is not done. This is incomplete. Just so you know, I know that this kind of conveys information, but it's not complete. To complete this, you need to rewrite it so that you just have your x to the n all by itself. So I have 2 to the n times x to the n. So think of this as the coefficients for this polynomial of sorts. So you have 1, 2, 4, 8, 16, and so on are the coefficients for the x's. And then down here, this 2x goes in here. And then just tell me what we do next down there with that inequality. Andrew, what would you like to do to make this inequality better? I'm sorry, what? Oh, divide by 2. Sorry, yeah. Just that's gotta work on. Maybe I need some hearing aids. Deal with that later, though. Very nice. And that's it. We're done. Notice that there's no limits. There's no ratio test. That when we're dealing with the geometric series, we already know where the thing converges. So there's nothing to do. Well, let's take a brief interlude or intermission just to mention the end of course surveys that are, you probably got an email this morning. And I know that it's hard. It's hard to figure out how to rate people and so forth. So I thought I'd give you a little bit of help here. Is if you don't know what answer to give, you can always just choose this as your answer. But seriously, though, leave some notes or say something if you want to in the body of the that's where the professors here are really excited when we get to read something and you say something funny. I don't know. But yeah, so as you're doing, not just for me, but for all of your professors, please do leave comments. We get our numbers, whatever. Someone cares about the numbers, but a lot of people, they just go right to the end and they read the comments, and that's really what is encouraging or maybe discouraging at times. I've had people comment on my shoes. I don't know why. I just remember, get some new shoes. Like, okay. I'm wearing hiking boots. I don't know why. This semester I can't wear my dress shoes. Okay, but let's get back to this. Let's do this one. The same deal. You know the drill. So I'll write down what we want to make this look like. So that's the goal. Make it look like that. So we're going to need a 1. We're going to need a minus. So I'll give you a minute to see if you can figure it out. There's a couple of ways to do this, but there's going to be one way that's going to be easier perhaps than others. So this probably is going to take a couple of steps to get it to look like that. So let's do one or, just as long as we get something done. Karen, what would you like to do? Is there anything that you see as different between these two? Yeah, the 2, it should be a 1, shouldn't it? How can I turn a 2 into a 1? Was it? Well, if you had a 2 and you wanted to multiply it by something to turn it into a 1, what would you multiply it by? 2 times what equals 1? Like, what number can I multiply 2 by? Solve this equation. 0.5, yeah. Sorry, yeah, it's just I'm doing a poor job of communicating. So there it is. Let me get rid of this. Yeah, so 0.5. So if I just multiply, you don't like the 2. The 2 is bad, right? We don't like the 2. So let's turn the 2 into a 1. How do we turn a 2 into a 1? Well, we're mathematicians. We can do whatever we want. Multiply by 0.5. 0.5, but we're careful when we do our mathemagic and we just multiply the top and bottom by the same thing. Now that's going to turn the 2 into a 1, isn't it? It is. So we have 0.5 over 1 plus 0.5x. All right, we're well on our way. We're doing great. You know what I'm going to do? I'm going to write it down here so I can zoom in better. And I'm going to put this 0.5 out here because I suspect that that's going to be a problem as well. There we go. Okay, because you probably also don't want to have anything up here. You just want to have a 1. So now Karen's happy. She's got her 1 here. I'm happy I've got a 1 here. You're probably a little sad about at least one thing there. Let's see if we can find someone. Maggie, what else do I need to change here to make this into that? That's it. We don't like the plus. We want it to be a minus. So let's do that and do exactly what Maggie suggested. Change it to 1 over 1 minus, and just make this negative. That's fine. All right, now are we happy? I think we're happy now. What do you think, Michael?
Couldn't you have also done 1 minus and then in parentheses negative 1 minus x?
You sure could.
Okay.
And I was hoping no one would do that. No, but no, we'll come back to that. No, that's absolutely true. Here, no. I'll wait till the end. No, this is good though. That's a great way of doing it, Michael. So thank you for bringing that up. We'll compare. Honestly, yeah, I was hoping to just gloss over that, not talk about it. But no, it's good to talk about it. So let's get our final thing here, this one. So now that we've done this, Red, what is the value? What is R for this thing? Did you say negative? Did I hear you? You just aren't a very negative person, I know, but here we do need the negative. So here R is negative 0.5x. And so in this case, this thing is going to be 0.5 times the sum, where n goes from 0 to infinity, of negative 0.5x to the n. We're not done, but we're close. So let's just clean this up a bit. Let's see, how can we do this? Here we go. Let's do this. 1/2 times negative 1/2 to the n times x to the n. Okay, I think I'm going to be done there. Just in case you're looking at that saying, where did all that come from? So the 1/2, the first one, I moved this back inside the parentheses. So 0.5, 1/2, because your book, if you look in the back of the book for the answers, it's going to have 1/2, it's not going to have 0.5. And then this negative 0.5 to the n, just negative 1/2 to the n, x to the n. One last thing about the book is the book would probably actually separate out the negative 1 and the 2. So if you look in the back of the book, if this was a problem in the book, it probably would have negative 1 to the n over 2 to the n plus 1, because you'll fold that in there. Oh, interval of convergence. That's easy enough. If this is r, then negative 0.5x has to be between 1 and negative 1, right? Which means that means 2 is greater than x is greater than negative 2. So how did I get these 2's? Well, I divided everything by negative 0.5. And when you multiply or divide by a negative number, you have to change the direction of your inequality. But of course, we're not going to write it like that. That looks dumb. Let's write it like this. So there's my interval. So I want to make sure everyone's happy with this before we take a look at what Michael did, because what Michael did is perfect. It's brilliant. But it's going to be a different answer. So we need to acknowledge that there are more than one way to do this. But is this one okay? Anything here that needs to be dealt with? Okay, let's go and check out this. I love this. So let's take a look at Michael's method. So I'll do this in a different color so that we can keep track. There it is. So let's see here. So this is going to be 1 over 1 minus negative x minus 1. Is that what you said, Michael, or something similar? It might not have been that exact thing, but that works. So if you compare this fraction with this, it's the same fraction. It's just been written differently, hasn't it? It's the same thing. So these are the same. So let's see what happens when we work with this. So this one looks like it's less work, right? So r is negative x minus 1. Very nice. And so you have this summation, the sum where n goes from 0 to infinity of negative x minus 1 to the nth power. But of course, the book wouldn't like this. You would want to separate out, let's see, do this. N goes from 0 to infinity of negative 1 to the n and x plus 1 to the n. So this makes the book happy. Let's see if I can explain why. First of all, you have the negative 1 to the n. It's an alternating series. And then you have this x plus 1 to the n. And that's the way power series look. Sometimes you have this. And to be honest, in this particular section, all of them, I believe, are going to look like this. But this is just another way of doing it. And this just means that your interval of convergence is going to be a little bit different. It's going to be centered at x equals negative 1. In fact, let's get our interval of convergence. The interval of convergence is going to be, let's see, this is r is going to be negative x minus 1 is between 1 and negative 1. And then let's just go ahead and negate everything and then switch around so that I don't have to mess with I know that this is actually 2 steps. There we go. So, you negate everything and it changes everything, the direction, and then you have to flip everything around. It all ends up looking like this, though. So that means that x is less than 0, greater than negative 2. So this is the interval of convergence for this power series. And interestingly, this is the interval of convergence for that power series. And they both approximate this function up here. If I was anticipating this, I would have graphs of all three. And you would see that Michael's his power series only converges between negative 2 and 0. This one here converges between negative 2 and positive 2. So one might say it's better, but there might be a reason why that one over there, the one in blue, is more appropriate for whatever problem you're working on. But they're both power series, so without any other restrictions, I would take either of them. I'd be thrilled. So do this on a test, Michael. I will give you 100%. Good job. So thank you for bringing that up. Okay, let's go look at another one. Hold on a sec. I want to make sure we get. There's a couple that I want to make sure we get to. Here we go. I know you knew this was coming. So let's take a look at this one. So go ahead and do that. We need to find our value for r, and we're going to be using this 1 minus r, and then we'll do the summation, and we're going to get our interval. There. This one actually isn't too bad. It's mainly just identifying r. All right, where's my volunteer list? Very nice, Caleb. Caleb, you know what to do. What would I do to make that look like the 1 over 1 minus r? I don't care about the square. What I do care about is that plus there. Can I get rid of the plus and make it a minus? That's right. Do the minus a negative trick. 1 minus a negative. Very nice. All right, so far so good? I think so. Okay, so next we're going to rewrite this like this. So this thing becomes negative x squared to the n. Let's make that look a little prettier. N equals 0 to infinity of negative 1 to the n, x to the 2n. That works, doesn't it? Now, since, here, r, I should have picked someone to do this. This r is negative x squared, right? So that means that this is negative x squared. Now there's a little bit of algebra to do, and it's especially, you got to be especially careful when you're dealing with x squared, but I think we can handle this. We're going to, let's see, so this means that negative 1 is less than x squared is less than 1. So here, this is that two-step process, just so you know. I'm not just dropping the negative. I'm actually multiplying everything by negative 1, which changes the direction, and then I'm flipping the whole thing over. So whenever I do that from now on, I'll just say, put a little weird arrow there. That's okay. But now here we have to be extra cautious because there's going to be a temptation to say, okay, I take the square root of everything. But bear in mind that what this is saying is that x squared is between negative 1 and 1. We're not going to have the square root of negative 1 to get in our answer. As much as we'd like it, we aren't going to do that. You see, I know, it's sad. See, if x squared is between negative 1 and 1, and x is a real number, it means that x squared is actually between 0 and 1. However, when you do the square root of x squared, you're going to have an absolute value. And so you end up reintroducing the negative. So really there's another sort of, here, I'll write them out because this one's a new one. So here, this does this. 0 is less than or equal to x squared is less than 1. So technically that's true. But then you end up with this. You do the square root of 0 is less than or equal to the square root of x squared, which is less than square root of 1. So technically all this next step that I'm about to do is actually 3, I guess. And then this is 0 is less than or equal to the absolute value of x is less than 1. And then that ends up being this. So negative 1 is less than x is less than 1. So really there's a bunch of stuff that goes into this, and it's not that big of a deal when I have 1 and negative 1, but if you had 4 and negative 4, you'd have to be extra careful for your thing here. But there's my interval of convergence right there. So we're happy with that. Okay, that's that. And there's the series. Okay, now for, oh yeah, yeah, there's a question? No, you're good? No, just excited that we're getting ready to go. Yeah, everyone wants front row seats for the baptism, I know, because you want to get splashed. So we'll almost there. Here's the final one. Is this, of course, you knew it was coming because of this, right? So anyway, so let's do this one, arctan x. So what are we going to do? How are we going to do arctan x? Well, here's the deal, is that the arctan is equal to the antiderivative, or the antiderivative of 1 over 1 plus x squared. Plus c, don't worry about the plus c for now. Let's just ignore that because this is just too beautiful to ignore. So if that's the case, then what we could do is we could do the antiderivative of this back here. What's this? This thing right here, that thing. So that's what I'm going to do. Let's do the antiderivative of the sum, where n goes from 0 to infinity, of 1, oh, wait, sorry, got a little ahead of myself. Let's try again. Negative 1 to the n times x to the 2n. Did I have that right? Let me double check. Yeah, negative 1 to the n, x to the 2n. Okay, so dx, there it is. So just suspend the confusion for a second. Just think of this as, ignore most of this, just focus on the x to the 2n. You know the rules. You know the rules of antiderivatives. In fact, I'll just write down the stuff that I want you to ignore for now. So ignore this stuff, because that, you're just going to go along for the ride. But you know the rule for the power rule for antiderivatives, don't you? Let's see if you got it. Christian, do you know the antiderivative rule? Do you know what this becomes when you do an antiderivative? Like, what is that? Like, if it was x to the fifth. X to the fifth?
It would be 1/6.
Yeah, 1/6 x to the sixth. Very good. So Christian knows his rules. He says, well, we're going to add 1 to the power and then divide by that power, right? That's what he did to go from x to the fifth to the 1/6 x to the sixth. So let's do the same thing. This becomes x to the 2n plus 1 divided by 2n plus 1. Now, since we're doing an antiderivative, of course, I have to have a plus c. But I believe my plus c is going to be plus 0. Let me just double check, because I want this to equal the arctangent. And arctangent of 0 is 0. So c has to equal 0. So I suppose I could just make a little note down here that arctan of 0 equals 0. Arctan of 0 equals 0. So c equals 0. And so this here is the series, the power series representation for arctangent of x. So I don't know if you remember, but there was a point in time where I was saying, oh yeah, I know that particular series adds up to like pi or something like that. It's because of this. And if you do this, let's say that you do arctan of 1 is going to be this series. Give me a sec here. Let's see, 1. So you're going to plug 1 in for x. So this becomes just negative 1 to the n over 2n plus 1. And so what does that work out to? That ends up being 1/3 minus 1/5. Sorry. Why is that erasing the wrong thing there? Okay, 1/3 minus 1/5 plus 1/7 minus 1/9, etc. But that ends up being the arctan of 1. Arctan of 1, we know, is pi over 4. So if you add up all of this mess, you'll actually get pi over 4. So it's just kind of, I blew it, didn't I? It should be 1 over 1 minus 1/3. My eraser's not working. So there we go. 5th, 7th. I'm getting tense now. But anyway, so just interesting that that's the case. So what your job is going to be for your homework is going to be dealing with things like this or this. This one's a good example. What you want to do is figure out what R is and then rewrite your series for a geometric series, rewrite it with whatever the R is for this. And of course, this one's obvious. X cubed is R. So I'm not going to belabor this, but that's the sort of thing you're going to do for your homework for tomorrow. So hopefully that does it. I'm going to stop the recording. If you